Hi everyone, in today's challenge we are going to solve this problem. The problem name is coin change part 2 and the problem number is 518. Alright guys, so first of all what we are going to do, we are going to clearly understand the problem statement. After understanding the problem statement, then we will move to the logic part. In the logic part we are going to see how we can solve this problem. What is the logic we are going to use to solve this problem. So after understanding the logic part, then we will move to the implementation part. In the implementation part, we are going to implement our logic in Python, C++, Java and JavaScript programming language. Fine guys, and guys, if you want to have a look on the solution, which I'm going to write in this video for Python, C++, Java and JavaScript programming language, I will share the link in the description. You can go through that particular link and you can find all the solution there, right? Fine, now let's see what this problem says, right? Let's see the problem statement. So problem say you are given an integer array coins, right? So we are given first of all an array. Let's write here integer array. First input is clear, right? An integer array. Fine, and after that representing coin of different denomination and an integer amount representing a total of amount of money. Second is nothing but we can say an integer only, right? So with the first line only we have understood that what are the inputs, right? First input is nothing but an integer array. Second input is nothing but we can say an integer only, right? So the integer array name is nothing but we can say coins, and here we can say it is amount, right? So name is also given, variable name. Fine. Return the number of combinations that make up that amount, right? First of all, let's understand this integer array is nothing but what? Coins. Means nothing but this integer array will hold the different coins, right? Representing a denomination 1, 2, 5. That means nothing but coin of 1 rupees, coin of 2 rupees, coin of 5 rupees. Simple thing. I would mix. If you are understanding in the Indian currency, right? If you're understanding in your we can say country currency, then you can assume like $1 any other language, right? So this is simple, nothing but we can say this denomination of coins, right? So 1, 2, and 5. One amount of money, two amount of money, five amount of money, right? Fine. Now what we need to do, return the number of denomination that, let me remove this, that make up that amount, right? Now what we need to do, guys, simple thing. So let's say we have this, right? Simple thing, 1 to 5. Let's assume that we need to, we have need amount, let's say 10, right? If we need a amount 10 and we have this kind of coins, right? One amount unit of coin, two unit of and five unit of coin, right? So what I can do, I need to find different possible number of combination which I can make, right? We return the number of combination that make up that amount, right? How can I make this 10 amount by using a this coin? I can say if you add 5 and 5 twice, then you will get 10 amount, right? So you can have in your hand two 5 coin, then you will get a 10 amount. But if I just say I will have 5 times 2 coin, then I'll also have a 10 amount, right? So this is the simple thing, guys. I hope you are understanding. There is a different possible ways to get a 10 amount from this particular set of coins, right? I hope it makes sense. So just that thing only we need to find. Return the number of combination that make up that amount. So just you need to return what are the total number of ways you can get a 10 amount by using a this coin, right? And last thing, if that amount of money cannot be made up by any combination of the coins, return 0. If you could not able to make, let's say you need to make amount, let's give it a name of let's say 10, and you need to make a amount of 1, right? So can you make amount of 1? You can't, right? You don't have a coin of 1, right? And you can't have a coin of less than 1 so that you can add some multiple coins, right? You cannot make a amount of 1, right? So you have to return here but 0, right? I hope it makes sense, right? So let's keep it again 2 and let's keep it again, right? Now you may assume that you have an infinite number of each kind of coin. Now guys, these number of coins you have infinite. You can use 2 coin 10 times, multiple times, 100 times, as much as you want, right? So as many times as you want, and 5 and 1 as well, right? So this means nothing but coins are present in an infinite amount of infinite time, right? So after that the answer is guaranteed to be fit in the say sign with 32-bit integer. Simple thing, guys. Now we don't need to care about modulus as well, like you have to return answer 10 is 1 more, 10 is 1 9 plus 7 more, so anything else, because they have make us test cases like that. Your answer will always be come in under the 32-bit sign integer, right? So you don't need to take over long and anything else. Fine. Now let's see the example one. In the example one, we have amount 5. So let me just remove all this thing. Now we have understood the problem statement. Amount is nothing but we can say about 5. Amount is 5 and coin is nothing but 1, 2, and 5. That means nothing but 1 coin, 2 unit of coin, and 5 unit of coin, right? Now I want to make amount 5, right? How many possible way I can get? They have clearly mentioned, right? You can directly take a 5 coin, you will get a 5. You can take 2 coin 2 times and 1 coin 1 time, you will get a 5. You can take 2 coin only 1 time and 1 coin 4, we can say 3 times, you will get a 5. And you can take all the coins of 1 unit of, right? 5 times, you will get amount 5. So these are the possible way. 1, 2, 3, and 4. 4 possible way you can get amount 5. And you have to return just answer 4 only, nothing else. You don't need to return these also, like 5, 2, 2, 1, 2, 1, 1. You have just have to return the number, right? 4. 4 means nothing. There are 4 possible way to get a 5 amount by using a this number of coin. I hope it makes sense, right? I know it's like I'm doing a little fast, but I hope guys it's a simple problem. Simple, we are given one array, we are given one integer, we have to just find out how many possible way we can get that particular amount by using the coins, right? So in the second example, we have amount 3. Let me just update at 3, and the coin is only 2, right? So can we make amount 3 with the 2? Obviously not, right? Even if you're taking single time, you will get less, but you need more. You need a 3 amount. So you have to add something, right? But you can only add 2 again. So if you add 2, you will get a 4. So that means that you are going to return 0. There is no way, right? Then you have amount 10, and you have also a coin of 10 unit, right? So what you can do, simple thing guys, simple, take one time only, you will get your answer, right? And if you take twice, then you will not get your answer, you will get 20. If you take 0 time, then also you will get 0, right? So in order to get amount 10, you need to take only one time 10 coin, right? And you can say return 1, because there is only one possibility. I hope it makes sense, right? It is simple problem, right? So simple thing, let me summarize this. We are given one array of coin. Second thing, we are given an integer, which we can say amount, which we need to arrange, or which we need to we have to make amount, this much amount, by using this coin which is present in this array, right? Simple thing. Now we have to find all the possible way such that I can get this amount by arranging any order of these particular coins, right? And it's not necessary to take all the coins, and it is given that we can take infinite time of coin, right? Infinite amount, infinite time that particular coin again, right? So that is a simple problem. Now let's see the logic part, right? I hope you understood the problem statement. And if you still have any kind of doubt, you can write in the comment section, guys. I'm always there to help you, because I don't know here what actual doubt you are facing, right? You can write in the easy comment section. Now, guys, let's see the logic part, how we can solve this problem. So if you don't know recursion, I'll suggest do solve a recursion problem a lot, right? But here also you will understand recursion how work, but still you should solve it, right? You should know recursion, because a lot of problem is going to come based on the recursion in the future as well, right? Fine. So recursion. Now, how we are going to use recursion? Recursion is not necessarily DP also, right? So basically, DP, you know, guys, DP is two type: tabulation, memoization. So we can say tabulations, top-down approach, bottom-up approach, right? So here we are going to use the DP only, but we are going to use a recursion. With the recursion, we will memorize it. And tabulation is quite easy. You can easily do it yourself as well. But still, you are not getting. No, we will see it at that part as well, right? But for now, recursion. Let's see recursion. So recursion, what we are going to do? We are going to say we initially make a recursion tree, right? And here recursion tree, I'm going to take a first example only, amount 5 and 1 to 5, right? So let me just scroll it down. So let's see here. So guys, I have amount what, amount 5, and coins array is number 1 to 5. Now guys, what should I take on my node, right? As you know guys, for recursion you should know what is a recursion tree, right? You should make a recursion tree in your copy as well, right? So here same thing we are going to do. We are going to make a node which is going to store index, and we can say amount, right? What is the index? Index is nothing currently where you are standing. I'm standing at 0 index, means nothing here. So for now, I can say my index is nothing. We can say 0. And what is my amount? Amount is 5. I need to get a 5 amount. Simple thing, guys. I need to make a amount of 5 amount, right? And I have standing at a 0 index currently. So what I can do here, guys, recursion tree will say. So from this node, what you can do? You can take this particular amount 1, right? Or what you can do? You cannot take this amount, move to the next one. So I'm saying that okay, I'm taking a this one amount. So now if I'm taking a one amount, I will still there, right? At 0 index only. And 5 minus 1 is 4. Now I just need only 4 unit of amount, right? Because I have taken a one amount and it's standing at 0 index only. Same thing, if you're not taking it, you will go to this particular 2, right? So this 2 is nothing but at 1 index, and you are not taking, so you will have only 5 amount in your hand, right? You need to take again a 5 amount only, but you are at now first index. I hope it making a sense, right? I know it's maybe complex for you if you are understanding this first time, but recursion tree must. If you understood this tree, you can easily make your we can implement this part. You can easily make your code as well, right? After that, once you are at here, again you are at 0. Same phase. Either take this particular one or move to the next one. So if you're taking again a 1, so you will say fine, I'm taking again a 1. So I will say I'm still at 0 and I have 3 now. I'm not taking this one now. So let me just mention here. Taking it, not taking it. Right? Fine. So I'm not taking it here. So what I'm saying, I'll say fine, I'll move to the 1 index. I'm saying I have a 4. It makes sense, right? Fine. And here for this one, first of all, let's solve this only, right? Because recursion, how this recursion, this will work like this one. Fine. Okay, why it is opening? Fine. So we are at 0 index and we have 3 amount, right? Again, the two option. Either I can take it or not take it, right? And my array was nothing but this only, right? 1 to 5. So at 0 index, I can take 1. So if I take 1, so I have to decrease 1 unit from my amount. So I will say 0. And amount is nothing but we can say 2 now. And if I don't take it, then I will say I reach to the 1 and amount is nothing but we can say same 3. Fine, come to bottom. So again I can take it or not take it. If I'm taking it, so I'll 0, amount is left 1. If I'm not taking it, 1, amount is saved 2. Again I can take it or not take it. If I'm taking it, again 0, and amount is also gonna be now 0. And if I'm don't take it, 1, and amount is 1, right? Now guys, here I'm not gonna recurse it. Why? Because now you can see my amount is 0. So if I'm getting amount 0, that means I have collected my money. If I collected a money, I'm gonna say return 1. This is going to return 1, right? Fine. And now let's move to this one. So here you can see amount is not 1, right? It is, we can say amount is, we can say not equal to 0. So we're going to proceed here. But here you can see it's 1 index, right? From 1 index we can take it or not take it. If I'm taking it, so we have to, if we are taking it, that means we are taking 2 unit of amount, right? So if I'm taking it, so I will reach to the 1 in only. But amount, if I'm taking, let me give it a space here, right? So if I'm taking it, let's say I will be gonna be at the same index 1 only, but I have to subtract 2 from amount, right? If I'm going to subtract it, I will get a -1, and which is not a possible case, right? So we can say this is going to be written 0, right? This is 1, this is 0, right? Let me just write simple here. This is 0, and this is nothing, we can say 1, right? Fine. Now come to this one. If I take it, if I don't take it, so where I will move to the second index, and I will say amount remains same. And this will also going to return us, we can say in the future this will also going to return a 0, because there is no possible way with this. Because you can see guys, that second index you will get a 5, right? So you will get a 5. So 5, if you decrease 5, you will get again a minus in amount, right? Your amount will be in minus negative, so you can say return 0. Fine. Now we come to this recursion part. Here we have 1 or 2, right? So that means nothing what we can say. Now this part we can take it or not take it, right? So if we are taking it, so what we'll do, we'll say remain the same index, and at what is the value at the second index, 1 index, it is 2, right? So if we are taking it, we'll get 0. 2 minus 2 is 0, right? Fine. So now you can see we got a 0 amount, right? So here it is also going to return 0, right? And if we don't take it, then we'll move to the second index, and here the amount remains same, and it will return 1. Why? Because at second index we have 5, and no, you can see there is no big less number than 5 in the future, right? So you can say return 0. So for now you can see guys, we have got 1 here, 1. Okay, I don't know what I'm done. It is going to be opposite, right? So we got 0, we have to return 1, here is 0, right? So you can see guys, we got 1 here, which is nothing but a combination of, let me write here, this is a combination of 1 1 1 1 1, right? So 5 times 1, you got the answer 1. And second combination is nothing but you got here 1, right? So which is nothing but combination of 2 and 2, you can see here 1 1 1 and 2, right? So you got two combination, right? 1 1 1 1, and one second is 1 1 1 and 2, right? So you can see guys, you got two things, right? I bit making a sense. Now let's move ahead. So here you can take it or not take it. If you're taking it, so you will get 1, and you will get 2. If you don't take it, so you will move to the next index, amount remains same. So here you can see there is no possible way, no, 2, it's going to be 1, right? So you are taking a second index, 1 index, which is 2 value, right? Fine. So it's going to be also going to give a 0, it is also going to give a 0. I bit making a sense. So now what I'm going to say, I'm going to say fine. Now come to this part. So 1 comma 4, either you can take it or don't take it. If you're taking it, so you'll say remain same index, subtract 2, and don't take it, move to the 2 comma 4, right? So it's going to say take it or not take it. If you're taking it, so you can say same index 0, otherwise 2 and 2, right? So it is going to return 1, again it's going to return 1, because we got a 0 amount. So you're going to add the second possible combination 1, taking a 2, taking a, not taking, this is not taking, taking a 2, this is taking a 2, right? So 1 comma 2 comma 2, this is also giving a 5, right? Fine. And this is going to give a 0, this is also going to give a 0, because you can see amount is going to be negative in future, right? Now let's see the second condition. If you're not taking it, right? So it's a fine, take it or not take it. If I'm taking it, then what I'm to subtract, I have subtract 2. So 1 index is 3, but if you're not taking it, so you will go to second index 5. So it is going to return in future 0. You can explore this later, but come to this one. So here I can take it or not take it, right? If I'm taking it, so I'll say okay, I will remain index at 2, and I have to subtract 5. 5 minus 5 is 0. So I can say this here, so I got amount 0. That means nothing but I have to return 1 here as well. So this is nothing but a 5. So what I can say, this is nothing but don't take it. So this is nothing, this is also nothing, but this is I think 5. So I can say this is the only one possible combination 5. So by this recursion tree, I hope you understood this recursion tree. We got our 4 possible options: 1 1 1 1 1 1 1 2 1 2 2, and only 5. And you can see on every case we got only 4 times 0, right? Rest of the time we are going to get negative, or we can say out of index, right? So I hope this makes sense. So just a simple recursion tree. What we are going to do, we can say either take it or not take it. Simple thing. In recursion tree, we don't need to write a 10 line of 100 line of code. Simple thing, just 4 line of code will be going there. Either you can take it or not take it. Simple thing. If you're taking it, Then you have to subtract the amount. If you're not taking it, move to the next index. Simple thing, right? And base condition already you have seen. If you got zero amount, return one. If you didn't, if you get amount in negative, return zero. And if you got out of index, return zero. Now let's move to the implementation part and let's implement this, right? And it's not gonna be a hard one, right? So what I can say simple guys, it's fine. First of all, I'm with the Python, right? So here I'm gonna say define source, and here I'm gonna say index. Recursion tree is gonna be of index and amount, right? What is the we can say whatever base condition amount is nothing but if equal to zero, then you have to return one. Fine. And if amount that net amount is your less than zero, means negative, or we can simply say or your index is out of bound is greater than or equal to length of coin. So what you can simply say return zero, right? So I hope it makes sense. So we have already seen these two base condition. Fine. Now what we can do, if it is not the case, then return solve. First of all, you are taking it. So you are taking, so index will remain same, amount will decrease. Fine, we have done. Second time we are not taking it. So we are going to increase the index, but amount remains same. Fine. So this is the simple function, right? Nothing we need to do is simple three line of code. Return solve. Index is going to remain zero. Starting from zero, amount will remain same. So can we do this? Let's see whether this working fine or no. If it's work, definitely guys, it is just a very easy problem. It should be the easy level problem, right? But I don't know why they have given a medium. So let's do three line. The thing is, guys, here why they have given a medium, you have to do a memorization. It's not a regression problem, it's a DP problem, dynamic programming. This same set can be repeated again and again, right? So what I can say in Python I can use it simply cache, but in C++, Java and JavaScript we will see how we can memorize it, right? So here I am just simply using cache. So let's try to submit this code. So let's see. Alright, so it's taking a time, but you can see guys, it's successfully got submitted, right? Just a simple three line of code without memorization. But if we do memorization, we'll see how long this code gonna be. So let's use a C++. And here guys, what we are going to say, we are going to find, first of all, we are going to say, let's create a map, right? Let's create a map. This is nothing but for memorization. So I give a name dp, then I'm going to return same function. So we are going to pass our index, which initially is going to be 0, an amount. Then what we are going to pass? We are going to pass our coins, we are going to pass dp. Simple thing, right? Let's define this function. So I'm going to int sol, it's going to take an index, it's going to take a vector of int. Okay, vector of not we can say ints coins, right? So it has to take amount as well, right? So int amount. And last thing, which is nothing but we can say map pair int, and here we can say int. How much long it's gonna be, I don't know. Fine. Now what we can do, we can simply say first of all, if our we can say what we could say, we can say amount is equal to 0, right? First base condition. If amount 0, return directly 1. Don't need to say anything. If amount is not 0, right? First of all, check amount is less than 0 or our index. So we can say index is greater than equal to our length of coins, right? Coins dot size. So what we can say, simply return now 0. We don't want to proceed further because amount is 0 either, or our we got out of index. Once this is also done, if we can say if it is also done, if it is also not the case, then we are going to say take it or not take it. Return solve. We are going to say index remains. If we are taking it, so index remains same. Amount will decrease. Amount minus coins of because index, and coins keep remains same. Plus so index will increase if we are not taking it. If we are not taking it, index will gonna increase, but amount will remain same, and points and dp remains same. Fine. So after that, what we are going to do? We are going to say fine, it's cool, but we haven't memorized it, right? We have used a dp, but we haven't used it yet. We have defined a dp, but we haven't used it. So we can say in here, if dp dot find, not dp find, dp dot find index comma amount, it is not equal to dp dot end. That means that we have already this key, right? So what we can say, we can simply return dp index comma amount, right? Fine. Now we are using it, right? So if we go to this particular state a, so we are going to return it, right? But are we storing this on? So we are not storing it, right? So we can say instead of returning, just give it a name result. And here what you can so you can simply say return before return store in your dp of index comma amount should be equal to now this result, and now return result. Now we are storing it as well, we are using it as well. Now let's see whether it's working fine or not. Let's see whether it's working fine or not. And you can see guys, it's working fine. It pass all these 3 test cases. Let's try to submit this code as well, and hopefully it should submit, right? But also you can see guys, in C++ also it's not a big code, right? Fine, it goes accepted. Now let's move to the next programming language, which is Java. Same thing we are going to do in Java as well. We're going to define first of all hash map. Let's define hash map. String is going to be a key, integer is going to be our value, name is dp is going to be new hash map. Fine. Now what we are going to do, we are going to simply say fine. We go to this thing. Now we are going to say int. Not int, just return whatever the sole function is going to return. Return. Sole function you have to pass what? You have to pass index, which in a thing is 0. Then you have to pass amount. Then you have to pass points. Then you have to pass this dp. Oh, it's a lot of things, right? Fine. So what we are going to do, we are going to find this function here. In this function, we are going to say int index, int amount, not amount, right? And here we can say int poem. And here we're going to also say hash map, right? Hash map of string, and we can say integer dp, right? Fine. Now what we are going to do, we are going to say fine if our amount is 0, again same thing, not 9, it is 0, then you have to return the word 1, right? But if amount is less than 0 or your index is greater than equal to points dot length, so you are returning a 0. We don't want to proceed further. But if it is also not the case, then you are taking it or not taking it, right? So you are storing in result. You are saying if one time I'm going to take it, so I'm going to solve index remains same, amount minus points of index, points remains same, and dp remains same. Second time I'm not taking it. So if you're not taking it, moving to the next index, and in the next index, and amount remains same, and points remains same, dp remains same. After that, this result you are storing in your dp, then so that you can use in next time whenever you're getting a same state, right? So before returning, you're storing in dp. So how you can store it? You can simply say dp dot put on the key. You have to put this result, right? Fine. After that, you have to return this result. Now, guys, you will say where is the key, right? So we have to define a key also, right? So guys, as we are using a string as a, we can say hashing, for hashing we are using a string as a key. So we can say our key is going to be nothing but in a string data type. String key is not nothing but index plus colon amount. So I have make a unique key, right, by using a index and amount, right? Fine. And after that, I'm saying that first of all check if our dp dot contains this key, then what you can do, you can simply say return dp dot get this key, right? Fine. If it is not the case, let me give it some space here. Fine. So first of all, we created a key. We are checking whether this key is present. So return this key. Otherwise, explore this part. Then after that, you have to return. Put this key in your DP. Then return this particular result. Right. Let's see whether it's working fine or not. And I hope it should work. Let's see whether we have any error. You can see, guys, all the rest is passed. So let's try to submit this code as well. And hopefully, it should pass. Right. Let's see. And you can see, guys, it's successfully submitted. Now let's move to the next programming language, which is the last JavaScript programming language. In the JavaScript, what we are going to do? We are going to say first of all define a DP, const DP, which is going to be new map, right? By now we are going to define a function, so which is going to take only two arguments here, index and amount, right? As this is a nested function. Fine. We are going to say if amount is 0, what we are going to do? Guys, you can tell easily, right? We are going to return 1. Fine. But if we have, let's define a key as well, right? So that key is nothing but we can say our index plus colon amount, right? So if our dp dot has this key, if dp dot has this key, that means you have to return dp dot get this key, right? Fine. If it is not the case, let's explore it. First of all, check if amount is less than 0, or we can say point with this index is greater than or equal to points dot length. That means that it is autobound or amount is negative. If it is the case, then you have to return what? 0. Fine. Now you're going to say either take it or not take it. So store in result. If you're taking it, so you're going to call a function solve. Index will remain same, amount minus point of index. Or if you're not taking it, so index will increase by 1, but amount remains same. Fine. After that, what you can do, you can simply say return result. But before that, store in your DP. So how we can store in DP? We can say dp dot set this key. We have to store in this result. Fine. And then you have to call this function, right? Solve with the index 0, amount remains same. Let's return this part. Let's see whether it's working fine or not. I hope it should work, right? Let's see. So you can see, guys, all the rest is passed. So let's try to submit this code as well. And I hope, guys, it should submit as well. Let's see. And it's taking a time, but hopefully it's submitted, right? So you can see, guys, we have done the implementation with Python, C++, Java, and JavaScript programming language. If you have any kind of doubt in the we can say problem understanding part, logic part, or implementation part, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet in the next video.